Hello again, this is Dennis Coskren, a geologist at Montgomery College, talking about my really fantastic minerals here, or at least I think so. This one is a sample of Afghanite, and it's actually an example of something that's very common among minerals in the Earth's crust. It's basically a jungle gym framework of silicon and oxygen, which is basically neutral. Quartz is the best example. Quartz is the commonest mineral there is. In this particular one, though, part of the silicon is replaced by aluminum, which means that the jungle gym type framework has a charge to it because the aluminum has fewer protons, and because it has fewer protons, it's left with an excess of electrons, which means that it wouldn't be stable unless you've got something to balance it. Well, it turns out the jungle gym has holes in it, and those holes are just right for putting in something with a positive charge to balance the lack of charge in the aluminum. In this particular case, there are a couple of things that go in there. One of them is sodium and calcium, which make up the charge. Those have a positive charge. But in this particular case, there's something even more unusual. There are sulfide ions that fit in the holes as well. Now, the sodium and calcium actually is extremely common in that the commonest group of minerals there is the feldspars. And that's how it works with them. You make up the charge with just the sodium and the calcium. In this particular case, you put in sulfide as well, even polysulfide, that is a couple of sulfurs linked together. And that's what gives it this pretty blue color in this particular specimen. That isn't always the case. Afghanite doesn't always contain the sulfide, so some of it is white. But this typical Afghanite from Afghanistan, the place where it was discovered, does have the sulfide. Okay, that's it for today. And
You'd have to write a structure, chemical structure.
If I've got the time for that, I'll be delighted to. Okay, Si, O, Si, O, 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 Si. This is just a two-dimensional cartoon. Each silicon has 4 oxygens. Each oxygen has 2 silicons. This is going to be in 3 dimensions, and this balances the charge exactly. But if I put an aluminum in here, then the aluminum, all the electrons remain the same, but there's 1 less proton in an aluminum because it's 1 step down in the periodic table. And that's where the charge imbalance comes from. And so that means we have to put in a sodium in here in the hole to make up the charge imbalance, to make sure that it all balances again. Now remember, this is just a 2-dimensional cartoon. We have to do this in 3 dimensions to make it more real.
Okay.
Okay?
That's a wrap up. Thank you, sir, Dr. Coskren. Yay.